Hello, people. I don't know. Nobody's replying from Munich, so I guess we can start. We have no visual feedback at the moment, but apparently they were already eating, which is kind of a mistake, in my opinion. How many of you are hungry? Okay. I guess you will need to last a couple of hours. Yeah. Otherwise, you can go to Munich because they're already eating over there. Okay, now. I need to have my slider. As you notice, we are experimenting a lot with Speck&Tech. A couple of times ago, we had an event where the companies were here pitching and trying to hire people. Then we had an event in the beautiful Duomo Square in the center of the city, which was also pretty cool and also different, also like something totally brand new. 200 people, a lot of food. It was raining, and we weren't enough, but we had 200 people attend the event. This time, we managed to divide the room and to split it in two sides. Because of this guy, he brought like all his house, apparently. Because we are streaming to Munich. We have the event at the same time happening here and at 400 kilometers far from here in Germany. So a big applause for us. So yeah, maybe for your side it might look the same for at least for the first. What the fuck this cable? Yeah, for the first 1 hour it might look the same, because actually we're gonna have a normal edition of Speck&Tech apart from this guy in the middle of my But from the next hour we will have the event from Munich streamed. So the first talk will be held here in Trento, and the second talk will be held at Celonis, which is the company that is helping us to make this possible. And it's actually at Theresienstrasse in Munich. Check them out. They have a very cool space, and they're already eating. I don't know if I told you already. Anyway, event number 23. This is not working, of course, because I need to. Yeah. Process mining. Who raise your hands if you know what is process mining? No, I need to pull it down. Cool, fantastic. Yeah, everyone was like, yeah, we do an event to process mining. What the fuck is process mining, yeah? No clue. So tonight we're going to have two experts telling us what process mining is and why you should be interested in that, because it's apparently something very cool. I still need to understand what it is, but they told me it's cool, so I trust them. Like, I'm a newbie when it comes to technology, so these guys are actually very, very hyped when it comes to very cool things to do for your company, for your work, for your life, for your tech savviness. So, for the people that don't know who we are, who doesn't know what is Speck&Tech, who's the first time here at Speck&Tech? Nice, nice, nice. So around 15 people. It's cool. We are like a community is growing continuously. Like I would say over 300 people at the moment, and every time we have like 10 or 15 new people. So actually, we are a community that is continuously growing, based in Trento. We started here 2 years ago. And we gather entrepreneurs, designers, developers, graphic people, students, everyone that is interested in tech, and to create a network of people that are interested in interested in tech. Is going, yeah. Yeah, an applause for the microphone. Yeah. So people that want to make create a network of people that are interested in tech in Trentino, and now we are actually expanding, because if you notice, Munich is not in Trentino, South Tyrol, or even like maybe some time ago when the king was here and the emperor, and we were like a big empire. But yeah, now this time is gone. So okay, anyway. We gather people that are interested in development, design, startups, any related topics. So if you identify yourself as one of these, you are a specker. So a person that pertains to Speck&Tech. We turned 2 years a couple of months ago, exactly on the 1st of March, which is, like people were singing happy birthday to Speck&Tech. It's pretty nice. These are the people behind Speck&Tech. Some of the faces, you might recognize them. Usually there's the other stupid guy here that is actually missing at the moment, which is Giulio. Julia, I hope you're like looking and listening to me. Yeah, but yeah, he's the guy leading now the event in Munich. But then we have a tons of people that are wasting their time in this beautiful thing that is Speck&Tech and coming here every single event at 6 or at 7 and starting wrapping wires and cables around the room and cutting spec and giving food for everyone and going to grab the food in Gardolo and buying the beers and everything else. So it's people that really devote their time and also all their time along the week to make this event possible. So I think they deserve a big applause from you, yeah? And of course, if you want to contribute to what Speck&Tech is, you're always more than welcome. You can come to an event a bit earlier and say, hey, I want to move some chairs. It's fun, you know, like it's beautiful. Like instead of going running around the Adige River, you can come here and move a couple of chairs. It's a nice thing. Or you can do another number of things, like saying I have a cool friend who's sponsoring the event, or I know a nice guy that's giving a talk, or I know one of my friends that might be interested in coming to one of your event, and you're like, yeah, come, because Speck&Tech is cool. Up to now, we've done over 25 events with more than 2,000 participants, which is looks like a pretty big number. We started with only 30 of you, and now we are almost 100 tonight. Plus, I don't want to count all of those that are in Munich, but you will see them later. And that's the reason why we started from Trento, and now we're moving to the beautiful Munich. This is just a one-off event, but nobody knows what's happened tomorrow, as they say. And tonight we have two awesome speakers. One is here with us, CHIARA, GHIDINI, a big applause for her. She is actually the one telling us what is this beautiful thing called process mining. I hope, yeah, because I want to learn. And then the second one is Manuel Haug. He's now in Munich. You're not going to see him for real unless you want to go to Munich tonight. If you live now, maybe you can manage to get the last beers for tonight in Germany. He's going to be the second speaker. You will probably listen to his talk in around 40 minutes. I guess you can start counting, because when he's going to finish, there's going to be spec for you. And tonight, since we are decentralized and working here and as well in Germany, there's this nice feature. If you go on slide.do, there's this website popping up that is telling you, do you have any question? And you can drop your question over there to one of the speakers. And when one of the speakers finishes their talk, even though they're in Germany, I will come to Michele, get the iPad, look at that and say, oh, there's a question from Martina, there's a question from Luca, there's a question from Anna, and it's going to be easier that way. You can also upvote or downvote other questions, so we skip the boring ones, or we keep the cool ones, or the most difficult ones for the speakers. So just go to slide.do, and the code is as Speck&Tech process mining. Pretty easy, yeah? Got it? Okay. Cool. You will see it later anyway. As always, before starting, a big thank to our supporter to make this event possible. Celanese is the company that is hosting our event, like giving us the physical spec and also the food for those fuckers in Germany. So I think they deserve an applause from them, not from... No. Now you will get to know more about Celanese in like half an hour when we move to Munich, and there will be a short introduction from them anyway. Impact Hub, as you may aware, is this beautiful space. Very hot at the moment. We'll need to find a solution for the summer. Anyway, maybe doing it outside, but it's beautiful. And like till half an hour ago, it was just a co-working space. So you can come here, get a desk, and open your startup in this lively space. EIT Digital is my organization. We do a number of things. If you're interested in a master course, especially in technology, in digital things, design, development, machine learning, AI, autonomous systems, whatever else is a buzzword, come to me. Then we have Belka, Giulio company. He's the guy now in Germany, but we have a number of people here working at Belka as well. They do mostly design of interfaces and products and another number of things, especially having cards on their Facebook pages. Then we have GitHub, Cloudflare, Factoring Cloud, and Diginate that are supporting us in any ways possible. especially if a touring cloud is giving us the fantastic software that we're using to get your donation. If you go there at the desk by Luca and you donate 1 single cent, we're gonna give you an invoice of 89 cents because the 11 cents go to the country, to the state. So we are very legal and we are proud of that. And even though you donate €1, we will give you a receipt, an invoice, I would say, automatically in your inbox. Check it out. And then we also have Diginate, that are the guys providing us with these beautiful stickers. If you don't have them, get them there. We soon will have the next edition coming. We are working at them, and we're also working at the brand new edition of the t-shirts. So if you are a guy wearing a S or a woman wearing a L, S, you might get the last t-shirts of 2017 edition, because now we're gonna work on the 2018 edition, and probably from June or July you might see them alive, touch them for real. I touched something, well done. Yeah, and this is Segata. It's our fabulous sponsor, giving us something that will fill your belly in a couple of hours, especially Speck, but also mortadella, bresaola, coppa, and all those things that like make me okay. If you want to see all the details about Speck&Tech, you can just go on our website and speck&tech. Remember that "and" is very important. Last time we managed to meet a guy from Los Angeles because he owned the speck.tech website. So you can go there and you can find all the previous issues as well, all the talks, all the speakers, all their contacts, their LinkedIn profiles. Just go there, it's fun, and you can also learn a lot of things from the deck slides of somebody else. And you can go on our website, on our Facebook page, and drop a like. It's very important to give us visibility and to help us doing what we do and achieve and reach to more people. And follow us on Telegram if you don't do it. We try not to spam. We send you max 1 message per day, which is fine. You can also mute us if you don't like us, but otherwise, yeah, no, people don't read it. Okay. And if you want to be more active, you can go on our Slack team. We have over 100 people there. They're shooting things like, hey, you know, guys, what's up? I want to open a website. I want to develop this. Do you know about the latest upcomings on GDPR? And so you can go there. It's pretty fun. You can also reach it from our website. So, final point of the night. Do you have to donate? And I always say no, because you are not obliged, it's not mandatory, but if you do it, you contribute and you give it back to the community and you keep the event running. You can also request a license for JetBrains. If you're a student, you get it for free. But if you're not a student and you want a JetBrains license, you can just go there to the desk at Luca and you say, hey, I want a JetBrains license, and he will say, get it, okay? So also the people for you in Munich, if you're interested in a JetBrains license, we have loads. So get back to us, send us a message, or talk to Giulio in Munich. He might be the one giving you a license. You're contributing to the spec, and you're contributing to the beers. Most of them are empty bottles at the moment, so it's good. We have a lot in the backyard, but actually they're paid from your donations, so that's what makes it important. Final point, we have a cool contest tonight. So if you're one of the donators and you're into electronic music, we are giving you 2 tickets for the Sticker Mule Festival. Sticker Mule is the company doing the stickers. If you are a cool specker, you also have that beautiful sticker of Speck&Tech, and the Sticker Mule is the one doing it. And actually they're giving us 2 tickets for this festival happening in Pineto, which is in Abruzzo, which is close to Molise. Okay, Molise doesn't exist, so it's close to Puglia. Actually, super cool. There are people like Apparat, DJ Cose, Alien Alien, like people that are really, if you're into electronic music like underground, you should go. It's on the beach. It's 3 days. A lot of fun, a lot of sun, a lot of beaches, and a lot of drinks as well. So yeah. If you are one of the donors, at the end of the night, we will draft them and tell you, are you interested in winning a ticket? If you are, you're winning 2 tickets. Otherwise, you can also say, I want to give it to the community, and then we will raffle somebody else. All clear? How boring I was? Yeah, thanks. Cool. Things getting serious. If you don't remember, this is the thing, slide.do, code spec tech process mining. Pretty easy. First speaker of the night, CHIARA GHIDINI from FBK.
Right, thank you. Can you hear me? Right. Okay, so that's my task, the task of introducing you to this cool thing of process mining, but I will probably try to explain you things in an understandable way. So I decided, I'm a teacher, so I decided to simplify things so that you can understand. If I'm too simple, just tell me and then I'll move faster. So basically the agenda of today is to understand what process mining is, to understand its three main tasks, that is discovery, conformance checking, and enhancement. I will skip the demo and I will tell you also a bit of this mysterious thing that is predictive process monitoring. So, who am I? Just a bit of introduction. I'm a scientist, so I'm not an entrepreneur or anything else. I'm just a scientist. I have a background in knowledge representation, and I see here in the audience some of my students in the logic course for a few years ago. So some of you already know me. I lead this process and data intelligence team at FBK. So if you are in Trento and you want to know more also in the future, you can also contact me. And I'm interested in business processes as a type of knowledge. So what's the context, let's say? The context is the one of process modeling. So business processes are, or business process models are a way of modeling procedures. And it's a simple way of, let's say, depicting the steps that you can perform from the input to the output in order to carry on a procedure. Think of the steps you need to do for, I don't know, obtaining an ID card from the government or something like that. But you can also see business processes as kind of pathways. So the roads I can travel in order to go from point A to point B. What's the point here? Is that, well, you can see procedures as a kind of planned pathways. So procedures are the roads that an organization paid for us in order to go from point A to point B. But reality also design pathways. So sometimes organizations plan things one way, but people do in different ways. And roads emerge from reality. So the point is that, can we ignore these paths that come from reality? No, for sure no. And process mining, this cool thing, is exactly this way. Is the way of putting together processes that follow the official design, so, and sometimes simpler abstraction of reality that follow the ideal way, and what actually feels like, or what actually people do, or what actually, I don't know, robots or other entities do in order to go from A to B. So process mining is exactly this. And just a bit of a disclaimer, if you want. People say that process mining is process management based on data. So you take into account data, so reality, a fingerprint of reality in order to model your processes. I would say that process mining is process management based on data and models. So models are an important ingredient. It might be my background in knowledge representation, but since there are a lot of young people here, I know you might all be enthusiastic of machine learning and just of, let's say, grinding and milling from data, whatever you can do, in a kind of black box fashion, so that you go from the input to the output without knowing exactly how you go from the input to the output. Well, process mining is not like that. Process mining is not the end of conceptual models, end of models. It's a way to put models and data together, right? So that's, for me, is the first thing that you should know and you should consider. That process mining is not the end of models, but it's a way of putting together models and data. Indeed, it has, let's say, four main ingredients. On this side here, on your left-hand side, there is the real world. In the real world, there are procedures. For instance, the procedure of granting a loan for your next house to buy, or the procedure of assembling a car, for instance, in a factory. So there are these things, but there are also the instances of these processes, of these process models, of these ideal processes. So the actual loan that was, for instance, granted to me for buying the house in, I don't know, Via San Pio XIX or whatever, or the actual process for constructing, I don't know, a Fiat Punto that has a certain ID number. So there are procedures, abstract procedures, and there are also instances. And on the computer-readable side, there is exactly the same thing. There are models that we can draw, and there are data, what we will call execution traces, that record the actual data of executing this process in an information system. And, well, I already said the importance of models, why models are important. And they are important in particular now because of this explainable AI thing or other kind of issues. If you want to decide something, or if you want to suggest something, and you want to improve something, and you want also to explain why, it is also important to have models that depict exactly the reality. So what do you need for, let's say, as a prerequisite for using process mining? Well, you need data, but you don't need whatsoever data. You need data represented in a process-oriented way. So here is just what could seem like a database. So you need usually tuples, right? But you need tuples structured in a particular ways. So you need tuples that represent events, so things that happens, actions. We want to trace the steps for going from A to B. So you need a database or something that represents events. You need to have an ID that identifies the object or the person or whatever things you want to trace through these activities. For instance, the ID of the car that is going to be built. And this ID, let's say, enables us to relate different rows of this, for instance, this Excel file. And what do you need? You need time. I mean, we are dealing with processes, so with sequence of activities in time. So you also need to know at what time an event occurred. You may have something like sophisticated, like a start and an end event, and an end timestamp, but you might also have a unique timestamp, so an instantaneous event. These are the basic ingredients. You may have other things, like for instance, who performed the action, the kind of object on which the action was carried on, or a lot of, the more information you have, the more informative models you obtain, but these are the main ingredients. You need to have events, IDs, case IDs, story IDs if you want, and a timestamp. That's it. Once you have these, you can download a tool, for instance, PROM. We will see at least a reference for that later on, and start your process mining adventure. What is the process mining adventure? The process mining adventure is, let's say, a way of having an happy relationship between models and data, and it's composed of 3 steps: discovery, conformance checking, and announcement. We will see them one by one, so I won't spend time in illustrating them in a quick way now. So discovery. Discovery takes an event log, so that Excel or that CVS file that we saw before with activities, case IDs, and timestamps, and gives you as an output a model. So you input the event log and you get the model. And why discovery is important? Well, it's important because in this way we discover, let's say, the traces, the execution traces that go through the plan pathway, like the lady there on the bike that goes through the actual bike path, but you also discover deviances. So you also discover pathways that are unexpected, that don't go as we planned things to go. Well, a disclaimer. Process mining, and in particular discovery, hurts. So you should, let's say, adopt these techniques if you are ready to, let's say, bear with the conclusion of your discovery process. So in particular in this thing, that, well, the math clearly shows that your project won't work, even if we do everything right now. And what should we do, right? Well, should we ignore this or should we consider it? And process discovery is exactly like that. It's putting people, let's say business analysts or experts, in front of what data tell us, and we need to be ready to bear the consequences of these things. So, I'm a teacher, so I thought that instead of, let's say, showing you super fantastic things, perhaps the Celonis people will show you more advanced things. I will get you the idea, or the super general idea, of how an algorithm of process discovery works. So you start with your event log, so this database of cases, activities, and timestamps. I've omitted the timestamps here. We just assume that the events are ordered, so the ones at the top occur earlier. And then from this log, we extract all the traces. So here is basically all the activities that pertain the case with ID 1. Here is the case, so the execution trace that pertains all the things that have a case ID 2, and then, for instance, case 3. Okay, so we've got steps of activities. How do we build the model? Well, we start, and this is the very general case, we start considering the first case. So the first case basically gives a sequential model which exactly corresponds to the case. So we perform A first, then B, then C, then D, then E. And then we consider also case 2. Well, also case 2 happened. Case 2, you can notice, starts with an A as the one before, but then it has a C first and a B then. Okay, so what happens? I, let's say, expand my model in order to take also into account the fact that from A I can go to C, and then from C to B, and then to D, and then to E, right? And then I take into account also the third trace. The third trace for the first part, for the top part, is fine. So I've got A. From A I can go to B, then I can go to C, then I can go to D. But here I have two Ds, right? So I add a loop on D. That's basically the basic idea of the model. As you can see, it's very simple. So what's the challenge? Well, the challenge here is that event logs are not composed of 3 traces. Event logs are big things composed of thousands or 100,000 traces. They are often very noisy. So let's say building representations that are clear and easy to understand, distinguish what the noise is from the actual traces, possibly clustering activities in order to, let's say, summarize a process that otherwise would be too big, are all challenges that people building process mining algorithms have to face. For instance, you can see that, I mean, if you see this model accepts a lot more traces than the 3 ones that I've got in my example. I might loop between B and C a lot of times, and this would be a trace that is perfectly fine for that model, but it never appears in my event log. So building then from these simple representation things that capture exactly all and only my traces that I have in the event log is not particularly easy. Also, another big challenge is to augment these models in order to understand, for instance, if the 2 arrows that leave or exit from A are in parallel or exclusive choice. This is not particularly simple because, let's say, sometimes the logs, I mean, this has to be done in a statistical fashion because logs sometimes have thousands of variations, and that's are all things that people working in process discovery work on. Indeed, if you go, for instance, to PROM, which is one of the typical open source tools that you've got developed by the academic community, you can find at least, I think at least 10, even more algorithms for process discovery. And they all give you different kinds of inputs with different kinds of precision or of characteristics, just to tell you how complex can become the implementation of algorithms starting from this very, very simple idea. So what kind of structures can I mine? I can mine this kind of graphs. These are called causal graphs, and usually more or less all the tools of process mining from the event logs enable you to extract these things. What are these things? Well, the triangle up there tells you that this is the start of the process, and then the arrows are augmented with a number that tell you how many execution traces basically went through that arrow. So in this, let's say, example here, I've got 100 traces, all of them start with A, 70 then continue with B, and then with D, and then with E. While other 30, they go from A to C, and then to D, and then to E, okay? And this is very simple to understand. We can also all understand that the branch there is an exclusive branch. So my 100 traces either follow the B route or they follow the C route. But then they can also extract things like that. This is a bit more complicated because, as you see from D, I've got also 10 cases that go back to A, right? Well, fine. Do we know whether these 10 cases executed B or C or some B or some C? Do we? From the diagram? Anybody for yes? Anybody for no? Yeah, okay, no wins, and it's actually the correct answer. So these structures are pretty simple, but they are not completely informative, right? So people, I don't want to go into details here, but people try to mine also more, let's say, complex and informative structures. These are called Petri nets. You can mine also BPMN models if you know what they are, but nets that enable us to say exactly, for instance, whether the fork is a parallel or an exclusive and things like that. And why this? When does this become important? Well, perhaps for process discovery not much, because as I said, sometimes here is a thread or a trade-off between simplicity and correctness, and causal graphs are usually simpler to understand. But if you want to move from discovery to the next step, which is, let's say, compliance checking, then you need to have something more formal. And instead of convincing you now, I will first explain you what conformance checking is, and then I will try to convince you by means of an example. So what is conformance checking? Well, conformance checking now assumes to have a model, okay, and assumes to have an event log, and tries to see how much the model and the event log are aligned. I mean, in that picture there is, as you see, there is a blocking, but people with cars possibly bypass this blocking, but going outside the road. Okay, so conformance checking is exactly this, discovering how many traces follow the rules and how many traces do not follow the rules. So how does this work? Again, in very simple ways. Assume that I've got my model, and assume I've got my case, so my execution, and now you see these little round things which enable us, or enable me to specify, trust me, that B and C happen in parallel, okay? So they both happen in whatever order. Parallel means that I can do B and then C, or C and then B, but I do both. So how does the algorithm, or how do the algorithms for alignment work? Well, they use this metaphor, well, of token. So you assume you have a token, and you have a token for the model, and you have a token for the trace. And then you try to move this token from start to end, both in the trace and in the model, by replaying the trace in the model to see whether I can reach the end in both of them. So I start and I've got my token at the end. So how do I move the token in the trace? I can move the token by synchronously executing the activity A. So my trace tell me if I have to, let's say, move the token from here to here, I have to execute A. And I can do it also in the model. So I move the token of 1, and since this is a parallel, this produces 2 tokens after A, one in order to execute B, and the other one in order to execute C. What does my trace tell me? Well, now I have to execute B. Can I execute B in the model? Yes, I can. Indeed, I can move my token forward. Now, the model tells me, well, yes, you have to execute C. Can I execute C? Yes, I've got the token before C, so I can move it, and then I have to execute D. I've got the token in both the places that come before B. I can do it, and then I do it, and then I'm done. So this trace is compliant, right? If I change my model, for instance, and I specify that B and C are in mutual exclusion, okay, and this is represented by this little thing there, trust me, what do? I do the same thing. I can do A, I can do B, but now my trace tell me, well, you should do C. But I don't have any token before C anymore in order to perform C and to move the token from before to after. So I can't continue, and my trace is not compliant. Actually, the tools and the algorithms of process mining also tell you often which actions you have to do in your trace in order to repair it and in order to make it compliant. So in this case, if you would remove C from your execution trace, then it would be compliant again. And your tools usually tell you, okay, you can repair this trace doing this and this. Right, what is enhancement? The last thing? Well, enhancement is actually changing the model, so producing a new model in order to, or updating an old model and producing a new one if you want, taking into account an event log. So you have a before and you have also an after. The point is this one. Assume you've got a model like the one there, and assume it was perhaps discovered or it was built by hand, whatever, we don't know. And assume now you've got 100,000 new traces that I've registered today. All of them are exactly the same, A, D, C, D, E. And they are not compliant. None of them is compliant, but because my model tells me that there can't be a D after an E. So what do I do? Do I assume that reality got crazy? That these 100,000 cases are all wrong? Perhaps no. Perhaps my model or my way of doing things, the way the world is doing things, has changed. And I need to incorporate this thing into my model. So a possible variation is, for instance, to add an activity D, which is in parallel to the old BC. Why adding things and not removing BC? Because I also want to maintain compliance with all the old traces that I've got. And this is actually one of the problems that people doing research on this or algorithms on this have to, let's say, deal with. The point is that the more variations I consider in order to, let's say, update and refactor my model, the more my model becomes, let's say, for the students who follow the logic course, a big OR. So you can do whatever you want in whatever format. Indeed, if you consider this model here, the only thing I know is that my sequence starts with A, it ends with D, but in the middle I can have whatever I want. These are called flower models in literature, and they simply say that, well, they seem nice, they seem small, but actually I can do whatever I want. And these are not nice. I mean, if you go to a business analyst, I don't know, if you're a business analyst and you go to someone in an organization with a model like that, it's really not informative. So it's a trade-off usually from the changes you have to do in the model and the traces that you want to maintain compliant. So these are basically the three tasks: discovery, conformance checking, and model enhancement. And these are the basic ideas, just to make you understand that the starting point was really simple. From that, you've got huge challenges exactly because of the fact that you don't have my three little simple traces, but you've got much more complex structures. From these ideas, people started developing tools. And there are nowadays open source tools and a lot of commercial vendors implementing these things. From the open, I mean, at least for the ones of you interested, for instance, students, in playing a bit with process mining, there are two open source tools, Apromore and Prom. In particular, the Prom, I would say, is probably the most, the oldest tool that gathered the research community together. And then I kind of started from A, commercial vendors starting from A and going on, but then I had to stop. There are really at least, I think, 50 or more vendors that implement tools for process mining, and Celonis will tell us more later on. So I won't go into the tools. I won't go into, let's say, applications, But just to say that one of my preferred applications for process mining is healthcare. Healthcare is a typical application in which you can discover processes, you can check conformance, and it's important because we as patients want to be treated in the way that is planned and required, and this is a big, big field of application for process mining. So that's traditional process mining, I would say. Then new things came. As you know, machine learning, for instance, about the explosion of machine learning and of prediction techniques is one of the things. And so what are the next hot or the current hot topics in process mining? I would say the three pillars you saw, there is still research, there is still ongoing research, but as you saw, there are also well-established vendors. So it's a solid and mature field. What people in research are doing? Well, a lot of things. One of the things that they are doing is to go beyond the three basic tasks and start dealing with traces in a predictive manner. So what is prediction? Well, predictions are everywhere. You well know that. And for instance, prediction is for processes is to understand what will happen next, or whether a next activity will happen or not. So, for instance, will Bob undergo surgery given his trace? So, what do you need in order to what do you need in order to perform predictive process monitoring? Well, you need a prediction problem, the thing you want to predict. You need to have historic execution traces, so past execution traces, and you need to have a running trace, the one for which you want to predict. Then you need to have, obviously, a tool or a machinery for doing prediction, and then hopefully this machinery will give you an answer, yes or no, or something more complicated. So let's go a bit more in detail and give you a kind of 3D perspective on predictive process monitoring. How can we classify it? What can you already do with it? Well, the first dimension is to decide or to understand what you want to predict. So the prediction type. There are three here, but traditionally there are three, and I will try to show you by means of an example. So assume there is two guys watching their noisy neighbor, which is John, okay? And John sometimes has kind of not very nice behaviors. So they have collected a lot of information about what John does every day, and what do they can ask to themselves? Well, they can ask them yes/no questions, like, will John turn the radio on? Or they may ask also categoric questions. Will John turn on the radio on, I don't know, Radio 1, Radio 2, Radio 3, whatever, Radio 105, whatever. So have a certain kind of outcome, I don't know, 10 outcomes, and asking which one of these 10 outcomes will be fulfilled. This is the first thing you can do with predictive monitoring, outcome-based predictions. The second thing that you can do is time prediction, okay? So we are thinking of, we have things that unfold in time, and so you can also ask yourself, when will John turn the radio on? And then you can also predict the next activity or the sequence of next activities. So what John will do from now on. This is the kind of things that you can do. Three things usually: outcome-based, numeric-based, and next activities. The second thing that you can, the second variable, let's say, that you can exploit is what you can use in order to predict. And let's consider this with a medical, let's say, trace. So you can use just the events, the activities, for instance, that are done on a patient, the blood test, the surgery, the X-rays, whatever. You can use also the data attached to these activities, what are called payloads. So for instance, the fact that the blood test had these, I don't know, hemoglobin, whatever results and thingies. And you can also use unstructured information. So for instance, notes that a doctor took. For instance, we ran an experiment on event logs recording the activities of a patient, let's say phone guy relationship in a phone customer care thingy, and they record a lot of things in NLP, in natural language nodes. Obviously, the more things you use, the more data you use, the more complex your techniques become. The third dimension is your approach. Perhaps most of you think of machine learning approaches in order to solve these problems, but actually there are also traditional model-based approaches, and they work this way. You have your traces, you first discover your model, you've got your model, and then your model is annotated also with time information, and then you run your current trace in this model, and you kind of simulate how much time it will take in order to complete. So you have both model-based approaches and also the typical traditional machine learning approaches. So you have to choose your model. So you've got to choose your prediction type, your input, and your approach. Now, is it all that we can do? Well, no, at least we scientists have a lot of creativity, and we want to consider a lot of things. No, I mean, seriously, there are real problems. And the real problems are, for instance, as you all know, if you played a bit with machine learning, hyperparameter optimization. So these techniques work, but discovering the exact configuration for which the algorithms work well on your data is usually a nightmare, especially if you use events, payloads, and all this sort of informations. Then you have to combine different techniques, possibly more than one technique for building your models. And can we give really a doctor the task of building these models, in tuning all these hyperparameters? Can we support people in doing that? We will see a bit of a short demo in 2 seconds in order to show you how we did, or a tool that allows to support in this hyperparameter optimization. So the doctor can avoid panicking. The other thing is obviously intercase predictions. So I've told you about predicting a running case as if we were all independent in the world. But assume I've got 3 patients in the hospital, and they are all, and I want to predict the next activity on them, and for all of them I predict that there is they need to undergo surgery, but I've got only 1 surgery room. That's not possible, right? So I really need to take into account, when I predict, the fact that we are in a world in which different cases can be running at the same time, and they can influence each other. Sometimes they are independent, sometimes they are not. The third thing is also a priori knowledge. I mean, sometimes I know that a doctor is ill. I know it already, and it's useless that the algorithm predicts me, I don't know, schedule a visit. The next thing that will happen is to schedule a visit with this doctor. So sometimes I've got variations in the word that I know, and I want, in a plug-and-play fashion, to embed this contextual information in my machinery. This is also a very active research field. I don't think there are tools that really do these things, but there are at least experimental algorithms that play with this challenge. So, as I told you, this is definitely a less mature field with respect to, let's say, the traditional process mining. There are few open source tools. One is Nirdisati. You can find it. Nirdisati is a Sanskrit word that means prophecy, if you wonder. Well, that's fine. I mean, I can, yeah. So, what's the idea? Then I will show you. The idea is that you've got a tool which is composed of 2 steps or 2 parts. One is the training, and the other is the runtime. In the training is this environment in which you can basically choose the best techniques for building your model. And how do? You basically use completed traces, right? So you know then the whole story. You pretend they are incomplete, so you hide some of the future parts, and then you train your models, or you compare, let's say, your techniques in order to understand whether what they predict is actually what happened. So you can really use it as a testing suite in order to choose the best techniques for your prediction machinery. Then you have a runtime part. Once you have got your best techniques and then you train your models, you've got a runtime part, and then you can actually do the prediction on the ongoing cases. So you can accept the different traces, and you can do the actual prediction. So let's see whether.
Let's jump to an introduction to the training component. GHIDINI supports several types of predictions. It can predict the completion time of each case, the next activity, the outcome, and even the workload per day. For each type of prediction, several algorithms are available, and selecting the one that performs best on a given event log is often a challenge. To help the analyst make the right choice, GHIDINI provides a web front end where one can upload an event log and test different machine learning algorithms. For instance, here, we've already uploaded the BPI Challenge 2017 log. This is an event log of a loan origination process at a Dutch bank. In the log overview, you can check the statistics of the log. Number of active traces over time, number of resources employed over time, and number of event occurrences. You can then train and validate the predictive model through the Predictions tab. Here you can select the type of prediction and the prediction algorithm. For instance, for an outcome-based prediction, it's possible to choose amongst different classifiers. Decision tree, random forest, and k-nearest neighbors. Let's select, for example, random forest for predicting whether the current case will be fast or slow. We need to specify the length of the prefixes to be used for training and validation. Let's assume that we want to make a prediction after 3 events. After the prediction model has been trained and validated, the validation results can be inspected in the Validation Results tab. In this tab, we can see, for example, the accuracy of the model using measures such as the F-score. The predictions per case can also be inspected in the Case-by-Case tab. Here you can see, for each prefix, the predicted and the actual outcome of the corresponding case. The Pie Chart tab summarizes the performance of the model, for example, by showing the distribution of fast and slow cases, both for predicted and actual results. Are you satisfied with the accuracy of the results? If you're not, you can go back to the algorithm section and try another algorithm. Otherwise, we can deploy the model and move to GHIDINI runtime. Once you've trained the required predictive models, they can be manually transferred to the runtime.
Right. So basically then you have a tab in which you can see the completed trace. You can, basically the idea is that you train your models. As you see, you can always in the training part compare what was the actual case, so how the real trace is completed, and what was the prediction that was made by your machine learning algorithm. When you are satisfied, you transfer the model, and then you start, let's say, registering, checking the stream of events that case by case, and then you have a tab that tells you that this trace completed, this is running, and in this particular example, we were predicting, where we were training an algorithm in order to predict whether a trace was fast or slow. So it was an outcome-based prediction, just fast or slow. And then you can see basically the prediction. So basically whether the trace that are ongoing will be fast and slow. And then you have a tab up there that tells you that at the moment you've got 649 running cases, you've got 636 completed traces. What are the what are the time that took for the traces to complete, and what is the average case duration that you predict. So this is basically an idea of a research tool. This is really a research tool that you can try. If you go to nerdisati.org, you can play with it. If you've got, you can, for instance, download event logs from the process mining website, which I will tell you later on, and then you can try a bit of this, of playing with it. So let me go back. Okay, so as you see, there is a bit of a difference in the sense that this is really still an ongoing research tool. The interface is so and so, but I hope it will get better, and perhaps, I don't know, in few years' time there will be vendors that also offer these suites per se. So what else? Well, actually a lot, but we don't have time to go into more details. So if you're interested, you can go to the www.processmining.org website. It's the website that the research community set up about process mining. You can find information about the prompt tool. You can find information about process mining in general. You can find successful stories or typical use cases of process mining. You can, if you're interested and you're old-fashioned and you want to read a book, you can refer to the, say, Bible of process mining, which is Will van der Aal's book titled Process Mining, Discovery, Conformance, and Enhancement of Business Processes, which is exactly what we saw, but a lot more in depth. And well, if you wanna maintain contacts, if you've got questions, things, if you got interested, if some of you, for instance, is looking for a thesis and want to work with us, then you can also contact me by email. Thank you.
Is it working? Yeah, cool. Thanks for the great talk. I was drinking your beer. Actually,
it's my beer.
Yeah, indeed. No, it's not working. If you use a single one, okay. Let's leave it. Okay. Questions. If you remember, there's this nice URL, but since we are here, you can definitely. Oh, there's a question. Incredible. Otherwise, get ready for yours, okay? I don't want to have only people from Munich asking questions. Like, we are cooler, no? Question. How much does Bayesian probability, or in general subjective probability, affect the research stage of process mining? From Anonymous. Thanks, Anonymous.
I'm not sure I understood the question, to be honest.
You can write a follow back, Anonymous.
No.
Mr. Anonymous, can you make the question a bit clearer? We will get it in real time. Meanwhile, we get one from here, from the audience. Anyone from the room that wants to ask more? Don't be shy, people. We are better than Munich. Yeah? Please. I'm gonna start making events in Munich from tomorrow if you don't make a question. Anyway. Nobody?
At least I can say that for sure, let's say, I'm not talking about probability, but frequency of events is an ingredient that you take into account in your process mining algorithms. So basically, you want to filter out, for instance, infrequent events or things like that, in order to get better models or more precise models that are easy to understand. For instance, one of the tools that you can use, one of the prompt plugins, can mine your process, considering all your activities. So basically, all the activities you have in an event log correspond to, let's say, a square. But you can also mine processes at different levels of granularity. So for instance, you can let's say, slider filter in order to say that the most frequent activities always appear as individual activities, and then you have big blobs saying, well, here certain things can happen, but I don't show you the granularity of these things. So you collapse more activities in one kind of macro process, and that's one of the things that happen.
We have a question from a guy named Anonymous, like for real. Can predictive process mining have applications in public transport, for example, in tracing user habits?
Yeah, indeed. I think so, in the sense that it has a great potential. I don't know of actual people, applications that actually performed case studies on that, but I would say yes. It can be used to trace these things and to trace whatever behavior. Whatever that can be split into a behavior, so for sure.
Are you enjoying the sauna? Yeah? Do you get it? Yeah. Oh, look at that.
Hi. What's the difference, if there is one, between data mining and process mining?
Yeah, nice question. I think it's the view on data, in the sense that, data mining are interested in defining rules that refer to static objects. So, for instance, the correlation between, the typical thing, the position of an object or a good in a supermarket and the user habits. So you basically identify patterns that concern static things, objects, while in process mining, if you wanna, it's pretty similar in the sense that you identify patterns that concern timed thingies, which are activities. So that's basically the relation. I think the idea from the very abstract point of view is more or less the same, is to identify patterns. Then you identify patterns between different things, and therefore the techniques that you use are different. Some of the methods, as you see, random forests or things like that, are techniques that also come from data mining. There is also an intersection in terms of techniques, yes.
We got another question. How much Speck is awesome? The serious one. Where does process mining has the most potential?
That would be for vendors more than me. Process mining has potential. As I said, I really like the medical domain environment, in the sense that, to me, it's one of the domains in which you have rather structured activities. It's important that you get things right, and it's important that you keep you maintain or you keep things under control. But I'm sure perhaps Celonis will answer better than me. Big organizations also exploit process mining because they want to understand what happens. The public sector could also benefit from process mining in order, for instance, to understand and monitor the execution of their procedures. How many people follow this path in order, to ask for this permission or that one. So this is another big sector.
We have a hint from somebody saying they actually did process mining for some squares in London. So it's, yeah. Can you highlight some limitations of process mining?
In which sense? A limitation for me already is the fact that sometimes it hurts and people want to go away after they discover the data. And this sometimes actually happens. It happened to me a couple of times that people didn't want to, didn't like the results. But this is a psychological limitation more than a practical one. To me, the most critical point of process mining is the preparation of the event log. This is still, let's say, a huge task, and it's often a manual task. Getting databases are not event-oriented. So databases are object-oriented. You store things about people, about products, about these things. You don't structure your databases in rows that contain activities. And sometimes, and also sometimes, the information about a process is stored or is spread in, I don't know, 10 different databases. So obtain the data in order then to apply process mining can be extremely painful, and it's usually much more time consuming than the process mining itself. So to me, up to now, let's say, this is the worst, the most important limitation, the fact that you need a lot of pre-processing in order then to use it.
Final question. Well, how much does it cost?
The tools, well, it depends on the tools, in the sense that there are 2 open source tools at least that you can use, and they cost nothing. So it's Apromore and Prom you can start using now, and then obviously the vendors have different prices for the different tools.
Because people here are shooting questions all the time. Stop, please. Okay, final one. In your experience, how many steps result useless in a business process? And will you highlight some differences between business process mining and process mining?
Interesting question, the second one. Well, how many steps are useless? I don't have guidelines. Or I don't have reliable statistics. It really depends on the use cases. Between process mining and business process mining, that's a difficult question to ask, in the sense that you could do something like that also on an industrial procedure, for instance, on a manufacturing thing that is not necessarily a business oriented in the sense of adding value, of selling something. I would say that typically the tools are oriented on scenarios that exploit, well, where you have activities, you have resources, so people who do things, objects on which you act, and these are typical examples of process mining. I would say that if you apply it to a stream of events, like, I don't know, events from a sensor, the techniques would need to be tuned. These techniques work well if you have a number. You can have big cases, you can have a lot of cases, but the number of activities that you can do are usually manageable. We are not thinking or talking about zillions of different types of activities, but we are usually thinking in terms of dozens of activities that you can do. In that sense, I would say I wouldn't rely on applying it to any generic process, but to something that is more similar to a business process, something where you have a reasonable number of steps for going from beginning to end.
Well, I slightly moved to the center. Thanks a lot again for the great talk to our first speaker of the night. The night is still long. I still need to move to this direction. Yes, lovely. Okay. You had a lot of questions. Well done. Maybe it was the people in Munich, but well done anyway. We have now a small break. You can go out and get some fresh air, because we definitely need it. Now it's gonna be like very smelly, this room, at some point. Anyway, we come back in a couple of minutes with the streaming directly from Munich, and don't leave the room, because in around 40 minutes there's gonna be a lot of Speck and a lot of beers for everyone. Cheers.